Let's continue solving quadratic equations using both quadratic formula and completing the square. In the last podcast, the first one we did, I think was a tie. Second one, I think I would have given it to quadratic formula in terms of ease. How about on this one? Right? So first of all, I notice it's not in standard form. I have to add 4 to both sides. X squared plus 2x plus 4 equals 0. I got stuck with a box there. Let's see if I can get rid of it. I hate looking at those boxes. There we go. All right, so A is 1, B is 2, C is 4. Quadratic formula, x is equal to, x is equal to negative b plus or minus square root of b squared minus 4ac, all divided by 2a. So x is equal to negative 2 plus or minus square root of 2 squared minus 4 times 1 times 4 divided by 2 times 1. So x is equal to negative 2 plus or minus. We've got 4 minus, so now we only have one negative, so it's 4 minus 16, divided by 2. Right, so x equals negative 2 plus or minus the square root, be careful, that's not 12, that's negative 12, divided by 2. And if you make that negative 1 plus or minus the square root of negative 6, I'm going to cry. I will seriously cry. All right, let's continue on. I'm just going to go across, okay? All right, so we have to simplify that radical. We've got a 12, right? And so we have a negative 12, right? So negative 12 is the same as 12 times negative 1, right? We can take the square root of the negative 1. We can also simplify that 12. That's 4 times 3. 4 is 2 times 2. We got a pair of 2's. 1, 2 comes out, 1, 2 goes away. All right, so we're going to have a 2 come out. So we have x equals negative 2 plus or minus. 2 comes out because of the negative, square root of negative 1, that's I. 3 stays in the radical. All divided by 2. Now everybody gets reduced by 2. Right? Because 2 is a factor for negative 2, for 2i, and for 2. Right? So if we divide negative 2 by 2, we get negative 1. If we divide 2i by 2, we get just the I, square root of 3. And then if we, I forgot the x equals. There, squeeze it in. And then 2 divided by 2 is 1, so now I no longer need it. I don't really need to put a 1 in there, right? So you have to reduce everybody. Got to remember to reduce the negative 2, the 2i, and the 2. Right? And so there's our answer. Negative 1 plus or minus I square roots of 3. This one took a little longer because we had some simplifying to do. Let's take a look at completing the square. Right? Well, I've already got the constant term moved. A is 1. I don't have to worry about that. Right? So all we have to do is add b divided by 2 squared to both sides. Right? Well, that's going to be 2 divided by 2 squared. Well, that's going to be pretty easy. X squared plus 2x plus 2 divided by 2 squared equals negative 4 plus 2 divided by 2 squared. So that's x squared plus 2x plus 1 equals negative 4 plus 1. On the left-hand side, that factors to x plus 1 squared, right? Because we have x plus 1 times an x plus 1. Right? It's always going to be x plus or minus, and that happens to be a plus. That's the third plus. I think some minuses in here. And then half of b. And half b is 2, so half of 2 is 1. Okay. So we have, on the other side, we have negative 3. Take square root of both sides. Don't forget plus or minus. Only thing that's going to simplify there, right, is that negative. Right? So that's going to become, square root of negative 1 is going to be the I, right? Square root of negative 1 is I. So, and then the 3 is going to stay in the radical. My last step is to subtract 1 from both sides. X equals negative 1 plus or minus I square roots of 3. All right, I think we all can agree completing the square won this one, right? I had a lot less steps to do. So take a look at the equation. If you've got coefficient of coefficient of 1 for A, B is even, an even number, almost always completing the square is going to win the race. It's a lot less work and a lot less steps and a lot less chances for me to make an error. I really didn't have very hard, very large numbers to deal with completing the square. I had to remember to simplify that radical on the quadratic formula. So, choose. Take a look at the equation. If completing the square is going to be done in it's just a few steps, it's probably going to be easier than the quadratic formula. Ooh, now I've got a coefficient. Which one's easier? It depends what the coefficient is. In this case, everything is divisible by 5. Let's take a look at quadratic formula first. Right? A is 5, B is negative 10, C is 40. Our quadratic formula, x is equal to, look how fast we did the problem twice in just like 5 minutes. X is equal to negative b plus or minus square root of b squared minus 4ac, all divided by 2a. So x is equal to negative 10 is 10. 10 plus or minus, we have negative 10 squared minus 4 times 5 times 40 divided by 2 times 5. So x equals 10 plus or minus, it's going to be 100, and that's going to be minus. So it's going to be 4 times 5 is 20. 20 times 40 is going to be 800, right? Because 2 times 40 would have been 80. 20 is going to be 800. All divided by 10. Lots of numbers divisible by 10 here. X equals 10 plus or minus. So that's negative 700 divided by 10. We have to simplify that the radical there. So 700, and it's a negative, right? So remember, we're going to have an I, right? And actually, I'm just going to write this. I'm just going to write the positive, and we'll just put the negative 1 right next to it so we don't forget. All right, so 700, the obvious choice is not to keep dividing by 2, but make that 7 and 100, because 100 is a perfect square. You don't have to split the 10s into 2 and 5s. You got a 10. One 10 comes out, one 10 goes away, 7 is prime. Right? So I almost have enough space to finish my answer. If I move you over, I want to block the completing the square part, but let's see if I do that. If I can just squeeze that in here. Or I'll just extend a page. Because I'm almost done. X equals 10 plus or minus 10i square root of 7, all divided by 10. Hope you see that everybody's divisible by 10. I probably move this down now. I didn't need the space. So we got to divide. That's a 10, not a 16. That one by 10, this one by 10, that one by 10. And it's got to be all three. So x equals 1 plus or minus, I don't need the 1, I square roots of 7. And I don't need the 1 in the denominator. There we go. That wasn't too bad. How does complete the square? So we're going to divide everybody by 5. So, don't shy away from completing the square if every single number was divisible by a. X squared minus 2x plus 20. Since when is 40 divided by 5? 20? Plus 8 equals 0. So now this one, it's not going to be bad. All right, so we have to subtract 8 from both sides. Minus 2x is equal to a negative 8. Our b divided by 2 squared is going to be negative 2 divided by 2 squared. We just had that one. So x squared minus 2x plus negative 2 divided by 2 squared equals negative 8 plus negative 2 divided by 2 squared. So x squared minus 2x plus 1 equals negative 8 plus 1. We can factor on the right. X minus 1 squared equals negative 7. Take a square root of both sides. Right? So all it's going to simplify out, square and square root cancel, is the I. Plus or minus I square roots of 7. Add 1 to both sides. X equals 1 plus or minus I square roots of 7. So, and originally, a problem that didn't look so good for completing the square, because you had an A term of 5, really wasn't that bad. I would say, though, this was a tie, because it really wasn't that, the simplifying really wasn't that bad either for the quadratic formula. So, I think this one's a tie. They're both winners. Either method would have been fine in this particular case. A little less simplifying on completing the square. Either method works pretty good. All right, so let's take a look at this one. All right, so we have 5x squared plus 154 equals negative 2x plus 49. First of all, we have to get this into standard form for quadratic formula. That means we're going to have to add the 2x and subtract the 49. All right, so everything's on one side. 5x squared plus 2x, and then 154 minus 49 is going to be plus 105. Right? Yes. Yes. Just double checking there. Equals 0. Well, if I get the same answer in completing the square, I'll feel really confident. All right, that I didn't make a silly little addition error there. All right, so our A is 5. Our B is 2, our C is 105. So we have x is equal to negative b plus or minus square root b squared minus 4ac, all divided by 2a. X is equal to negative 2 plus or minus the square root 2 squared minus 4 times 5 times 105. And divided by 2 times 5. 2 times 5 again. Obviously, we're going to have a negative number under the radical. So we have 4, and we have 4 times a 5 times a 105. X equals negative 2 plus or minus 4. And that's going to be 105 times 20. Right, so 105 times 2 would be 210. If it's times 20, you got another 0 in there. Right, so 2100. So you break things down, it's easier. Divided by 10. I think it's going to be an easy number to work with on either side. Negative 2 plus or minus. So 4 minus 2,100 is going to give us 1,996. No, excuse me. It's a good year, but that's not it. 2,096. I don't know where I came up with 1,900. Yeah, we had 4, we have 2,100. Divided by 10. It's an even number. It's probably simplifiable. Oh, and it's negative. Don't forget your negative there. So when you're using quadratic formula, because it can be easy to go into like automatic pilot mode, make sure you just kind of double check for little tiny things, like forgetting your negative there. 2,096. 96 would be divisible by 4, so I'm going to say it's probably divisible by 4. All right, so we have 5, and then we go into, so we go into 25 times, go into 9 twice, and we'd go into 4 times into the 16. All right, so 524, is that divisible by 4? I think so. That would go in once, 131. 131, I'm almost 100% sure is prime. It's not divisible. It's obviously not divisible by any even number. Not divisible by 3, because 3 plus 1 is not divisible by 3. Not divisible by 5, because it doesn't end in a 0 or 5. Not divisible by 7, right? Because 7 will go into 13 once, and then I'd have 61. Right? That's a prime number. It's not divisible by 9 if it's not divisible by 3. And it's not divisible by 11. That's 121 that's divisible by 11. So I think we can feel pretty confident that that's a prime number. So x is equal to 4i, right, because there was a negative. Let's just write it there to help us remember. And then, oops, how about the rest of my problem? How about the pretty little negative 2? Negative 2 plus or minus 4i square roots of 131, all divided by 10. All right, so everybody's divisible by 2. I'm going to extend the page in case I need that space for completing the square. So our last step is going to be right here. X is equal to, so we got to divide him by 2, that one by 2, and that one by 2. Right. That's it. Because that's the only number that all three are divisible by. Negative 1 plus or minus 2i square roots of 131 divided by, that just, it's like going uphill here. Let's try that, writing that one more time. 2i square roots of 131 divided by 5. Good enough. That's our answer. All right, so let's see how it works out for completing the square. We need the x terms on one side and the constants on the other. So let's add 2x and subtract 154. And then add 2x, subtract 154. The 49 is fine. So that gives us 5x squared plus 2x. And by the way, on this problem, I would not divide everybody by 5, right, because nothing was divisible by 5. Right? Don't make it worse with 4 terms. Get it to 3 terms, then you can divide by 5. All right, so 5x squared plus the 2x equals, we've got 49 minus 154. It's going to be the negative 105. Right? It would be just what we have over here, except the 105 moved over. All right, so now we've got to divide everybody by 5. So that's not looking great for this one. X squared plus 2/5 x equals, and that would be divisible by 5. It's going to be negative 21. All right, so b divided by 2 squared is going to be 2/5 times 1/2. Right, so that's x squared plus 2/5 times 1/2. Well, half of 2/5 is 1/5. That would cancel right there. So we have we've got to write the 2/5 x in first. 2/5 x plus, and then we'll have 1/5 squared equals negative 21 plus, can I squeeze it in there? Move everybody over just a teeny little bit. I got to get a 1/5 squared in there. So we have x squared plus 2/5 x plus 1/25 equals, let's not write it twice. Let's just change that. We know it's going to be 1/25. Let's change the negative 21. So we have to multiply it by 25. Right? So you can have 25 in the denominator. All right, so 25 times 20. All right, so 25 times 2 would be 50, times 20 would be 500. And I need one more 25, right, because it was 21. So that would be 25 times 21. So 525. So I just broke it down. Added up the 20s, 25s, and then one more. So negative, oh great, what did I have on the page? 525. Ooh. It's kind of squeezed in a little bit too much. Negative 525 25ths plus 1/25. All right, so now we can factor on this side. X plus half of 2/5 is 1/5. All right, just what we have right there. Another plus equals, so negative 525 plus 1, that's going to be negative 524. Right, so we'll take a square root of both sides. X plus 1/5 squared equals, oops, horrible looking 5 there. I think we're okay though. Plus or minus, I'm going to split that. Negative 524 is divided by square root of 25. So square and square root cancel. That's going to be x plus 1/5. Right, and then equals, well, 524. Well, we know what 524 is. It's right above us. So 524 is 4 and 131. So 2 and 2. 1, 2 comes out, 1, 2 goes away. All right, so we have plus or minus and then it's an I, right, because it's negative, 2I square root of 131, and then square root of 25 is 5. Now we just got to add or subtract 1/5 from both sides. X equals negative 1/5 plus or minus 2I square roots of 131 divided by 5. Did we get the same answer? Yes, we did. That's good. I would say quadratic formula, even though you had to simplify a little bit there, was still easier than this one. So if A does not divide evenly into your B term, maybe you'd rather use quadratic formula. You see that neither one was very difficult. Quadratic formula, I think, was a little easier on this one, right? But completing the square was easier. Well, this one was the tie, but completing the square was easier on this one, right? So they're both winners. We've got one for completing the square, a tie, and one for quadratic formula, right? If I didn't have to, if the radical wasn't so big when I'm writing, you can see that the other side has more steps. All right, let's do one more, but this one is quadratic formula only. If A is negative, divide all terms by -1 to avoid having to simplify the negatives later. You won't have a negative in the denominator if you divide by -1. You're more likely to make an error if you have that negative in the denominator. You don't want a negative in the denominator. So just take one teensy-weensy moment and divide everybody by -1. So now it's x squared plus 9x plus 12 equals 0. And that's much nicer. A equals 1, B equals 9, C equals 12. And so x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So that's going to be x equals negative 9 plus or minus, go fast, 9 squared minus 4 times 1 times 12, all divided by 2 times 1. Make sure I'm making any errors here. X equals negative 9 plus or minus 81 minus, there's only one negative, so that would be 48, divided by 2. So I have lots of space here, so I may as well just use it. X equals negative 9 plus or minus, so 81 minus 48 is going to be 33. Yes, it is. And positive 33. Sorry about that. I got carried away with my negatives there. But it is a radical. Square root of 33, all divided by 2. That's our final answer because although 33 is not a prime number, it's 3 and 11. And so nothing's going to simplify there. And let's just make a quick look at this. Looks okay. Looks okay. That's our final answer there. So nice, easy one to end this with. Thanks for, I do believe that's the last one. Let me double check. Yeah, because there's a closing question, and that's actually going to be moving someplace else. So this is our last problem. Thanks for watching. Bye for now.